Welcome dear students. Today we will discuss the straight line in the three-dimensional coordinate geometry. You have already known that general equation of first degree in xyz represents a plane. Means ax plus by plus cz plus d is equal to 0 represents a plane. And you also know that the intersection of two planes, just like this is one plane, this is second plane, and this is the line of intersection of these two given planes. So intersection of two planes represents the equation of a straight line. So we can represent a straight line as we write the two equations of planes together. This represents the line of intersection of the given planes. So a straight line can be put in the form ax plus by plus cz plus d is equal to 0 and a dash x plus b dash by plus c dash z plus d dash is equal to 0. Separately, these two equations separately represents plane. These are two planes, but if we write these two equations together, then this represents a straight line. And the representation in this form of a straight line is called unsymmetrical form. Now the question arises, x-axis, y-axis and z-axis are the straight lines. So one can ask, what will be the equation of x-axis, y-axis and z-axis in the unsymmetrical form? You know that from the figure you can see that here x-axis is the line of intersection of xy plane and xz plane. Equation of xy plane is z is equal to 0 and equation of xz plane is y is equal to 0. Taking together the equation of these two planes, the line of intersection is x-axis. So equation of x-axis in the unsymmetrical form is z is equal to 0 and y is equal to 0. Similarly, the equation of y-axis in unsymmetrical form is z is equal to 0, x is equal to 0. Similarly, the equation of z-axis in the unsymmetrical form is y is equal to 0, x is equal to 0. So you can tell the equation of coordinate axes in unsymmetrical form, or for remembering you can say, if one asks the equation of x-axis, leave the x, put y and z is equal to 0 with comma. So equation of x-axis for remembering purpose, y is equal to 0, z is equal to 0. The equation of y-axis is, leave the y, x is equal to 0, z is equal to 0. And the equation of z-axis is, leave the z in x, y, z, x is equal to 0, y is equal to 0. These are the unsymmetrical forms of the equations of coordinate x. Now, second form of the straight line representation is symmetrical form. So the question arises, what is the equation of a straight line passing through a point alpha, beta, gamma having the direction cosine L and N? See, this is a straight line. It is passing through the point alpha, beta, gamma. Say this line is AB and its direction cosines are element. Take general point P, X, Y, Z on this straight line. Then direction ratios of AP are X minus alpha, Y minus beta and Z minus gamma. And the direction ratio, direction cosine of AP are element. We know that direction ratios and the direction cosines are in proportion. So we get X minus alpha upon L is equal to Y minus beta upon N is equal to Z minus gamma upon N. This is the equation of a straight line in symmetrical form. So you can say that any equation of a straight line passing through a point alpha, beta, gamma having the direction cosine LMN is X minus alpha upon L is equal to Y minus beta upon N is equal to Z minus gamma upon N. This is the representation of a straight line in the symmetrical form. Now the question arises, if the equation of a straight line is given in the unsymmetrical form and you have to find out the equation of that straight line in symmetrical form. So we will show this problem as, since equation of the straight line is given in the unsymmetrical form, means it is given as two planes are given, a1x plus b1y plus c1z plus d1 is equal to 0 and a2x plus b2y plus c2z is equal to 0, and the line of intersection of these two planes we have to find out in the symmetrical form. So assume that the equation, the direction cosine of the straight line above represented is R, L and N. Clearly this line lies on the first plane, so it will be perpendicular to the normal of the first plane. Applying the condition of perpendicularity, we get a L1 plus BM1 plus CN1 is equal to 0. We are seeing that this straight line also lies on the second plane. So this straight line will be also perpendicular to the second plane. Again applying the condition of perpendicularity, we get AL2 plus A2L plus B2M plus C2N is equal to 0. Solving these two equations by cross ratio, we get this equation L upon B1 C2 minus B2 C1 is equal to M upon C1 A2 minus A C2 A1 is equal to N upon A1 B2 minus A2 B1. Since L, M and R proportion to these quantities, so we have find the direction ratio of the straight line whose equation is required in the symmetrical form are B1 C2 minus B2 C1, comma C1 A2 minus C2 A1 and A1 B2 minus A2 B1. Change these direction ratios into direction. Now we have known the direction cosine or direction ratio of the straight line whose equation we have to find. Now, one thing we need, that a point should be also we have to find out. So take the intersection of these two given planes with any coordinate planes, either with xy plane or yz plane or zx plane. Assume that we are taking the intersection of these two planes with xy plane. Xy plane means z is equal to 0. So put z is equal to 0 in the given two equations. We get a1x plus b1y plus d1 is equal to 0. a2x plus b2y plus d2 is equal to 0. These are the two equations in two variables x and y. Simply by solving, we get the values of x and y. The values of x we find is b1 d2 minus b2 d1 upon a1 b2 minus a2 b1, and the y is d1 a2 minus d2 a1 upon a1 b2 minus a2 b1, say alpha and beta. And the value of z is 0 because we have taken the intersection of these two given planes with the xy plane. So we have a point on this line alpha, beta and 0, where we have told you the value of alpha and beta. So two things are known. So simply we can write the equation of this straight line in the symmetrical form is x minus alpha upon n is equal to y minus beta upon n is equal to z minus gamma upon n, or x minus alpha upon b1 c2 minus b2 c1 is equal to y minus beta upon c1 a2 minus c2 a1 is equal to z minus gamma upon a1 b2 minus a2 b1. So we get the equation of a straight line in the symmetrical form. Okay. Now if we have to find the equation of a straight line passing through the 2 points, say x1 by 1 z1 and x2 by 2 z2. So the direction ratio of that straight line is clearly x2 minus x1 by 2 minus y1 and z2 minus z1. Then the equation of this straight line is given by either x minus x1 upon x2 minus x1 is equal to y minus y1 upon y2 minus y1 is equal to z minus z1 upon z2 minus z1, or x minus x2 upon x2 minus x1 is equal to y minus y2 upon y2 minus y1 is equal to z minus z2 upon z2 minus z1. So you got the equation of a straight line in unsymmetrical form and in symmetrical form. In the equation of symmetrical form, the equation of a straight line passing through the point alpha, beta, gamma, having the direction ratio ABC is x minus alpha upon A is equal to y minus beta upon B is equal to z minus gamma upon C. If we put it is equal to t, then find the values of x, y, z in form of t, and this is the third type of representation of a straight line, is called parametric representation of a straight line. Okay. The line intersection of a straight line and a plane. The intersection of a straight line and a plane. Suppose we have to find out the point of intersection of the plane ax plus by plus cz plus d is equal to 0, and the straight line x minus alpha upon l is equal to y minus beta upon m is equal to z minus gamma upon m. See here, this is the given equation of plane and this is the straight line, and we have to find out the point of intersection of this straight line and this plane. Clearly, how we will find out? Telling you that the equation of straight line is x minus alpha upon L is equal to y minus beta upon m is equal to z minus gamma upon A. Suppose it is equal to R. So the general point on this straight line is LR plus alpha, MR plus beta and NR plus gamma. General point means by changing the values of R, we can move any point on that straight line. So it is a general point. It may be everywhere on that straight line, depending upon the value of R. Suppose that this general point is the intersection of the given straight line and the plane ax plus by plus cz plus d is equal to 0. So put this general point in the equation of plane. When you put the general point in the equation of plane, simply you will get the value of R, and getting the value of R, put this value of R in the general point, we get the point of intersection of the given plane and the straight line. Clear? These are the main things. So we will tell you some simple 1 or 2 problems here. Simple problem. First problem, find the symmetrical form of the equation of the line. It is given in the unsymmetrical form 3x plus 2y minus z minus 4 is equal to 0, comma 4x plus y minus 2z plus 3 is equal to 0. It is given in the unsymmetrical form. We are changing this equation into symmetrical form. Suppose that the direction ratio of direction cosine of the straight line is R ln. So this line lies on both the planes. So this line of intersection is perpendicular to the normals of the both the planes. Applying the condition of perpendicularity of this line with the normals of the given two planes, we get two equations. 3l plus 2m minus n is equal to 0 and 4l plus m minus 2n is equal to 0. Solving by cross ratio, we find that l upon minus 3 is equal to m upon 2 is equal to n upon minus 5. So these are the direction ratio of the straight line. Direction ratio of the straight line whose equation we have to find out are 3, 2 and minus 5. So convert these direction ratios in the direction cosines. So direction cosines, we find that L is equal to 3 upon minus under root 38, M is equal to 2 upon under root 38 and N is equal to minus 5 upon under root 38. Now we have to find out a point on this straight line whose equation we are finding. So take the intersection of the given two planes with xy plane, put z is equal to 0 in both the planes, we get the two equations. 3x plus 2y minus 4 is equal to 0 and 4x plus y plus 3 is equal to 0. These are simple equations. Solving these, we get the values of x and y. X comes out to be -2 and y comes out to be 5. And z is 0, putting the values of alpha, beta, gamma. This point is alpha, beta, gamma, means alpha is equal to -2, beta is equal to 5 and gamma is equal to 0. So putting the values of alpha, beta, gamma and Lmn in the equation, x minus alpha upon L is equal to y minus beta upon N is equal to z minus gamma upon N, we get the required equation of the straight line as x plus 2 upon -3 is equal to y minus 5 upon 2 is equal to z minus 0 upon -5. This is the equation in the symmetrical form, and this is the required equation of straight line in symmetrical form. So study this topic seriously, solve some problems on the conversion of the equation of a straight line from unsymmetrical form to symmetrical form. Be fit in this corona period, study well and maintain your mental health and physical health in this critical period. Thank you. Thank you.